Hello children, so welcome to AIMS India's online classes. Today from physics subject, motion topic we are going to learn. One minute children. Okay. So children, our today's concept children, so velocity of the body on reaching the point of projection. So in this video we are speaking about a body vertically projected upwards. A body which is vertically projected upwards means vertically thrown upwards. So for throwing it up, we need some initial velocity u. We need some initial velocity u because the body is going up, but the gravitational pull will pull it downwards. So that's why in the beginning, if the velocity of is 40 meter per second, because of gravity, the velocity will decrease 30 meter per second, 20 meter per second, 10 meter per second, 0 meter per second. 0 meter per second. Means from this is the point of projection. From where we have thrown the object. This is point of projection. From point of projection up to certain height it will travel and its velocity will become 0. This height is called h max, maximum height. Yesterday only we have calculated h max equal to u square by 2z formula. H max equal to u square by 2z. So up to certain height it will travel due to gravity or due to gravitational pull. Velocity continuously decreases. Finally it will become 0. When the velocity becomes 0, it can't rise up, it can't go up. From there it starts falling down to the ground. Falling down to the ground vertically downwards. But in what way? Velocity is 0. Again it will become 10, 20, 30, 40. Like that velocity will be increasing while coming downwards and finally it will hit the ground. Means in what path it went up, in the same path it will come down and hit the point of projection. Hit the point of projection. Now the question is, velocity of the body on reaching the point of projection, how much? On reaching the same point again, after going up and coming down, after reaching the same point, what is the velocity that we have to calculate? So let's assume children, let a body be projected vertically upwards with an initial velocity u. So body reaches the point of projection. After how much time? While going up, time of ascent. While coming down, time of descent. This total of time of ascent plus descent is called time of flight. So means for time of flight means or it will reach the point of projection after the time of flight. After the time of flight. Okay. After the time of flight. After the time of flight, t. After the time of flight, t. Okay. After the time of flight, t. So we know that v equal to u plus ct. We know this formula. V equal to u plus ct. This formula already we know. Okay. So from this, so what we will do? Because the body is going up, gravity is acting downwards. They are opposite. So gravity is taken as negative because they are opposite. In the place of time, because after time of flight, it is reaching the point of projection. Because after the time of flight, time of ascent plus time of descent equals to time of flight. After time of flight, it is reaching the ground. So that's why time, we will take time of flight, du by z. So velocity, we have to find striking velocity. With what velocity it will strike the point of projection. So v striking we will keep. So in the place of v equal to u plus 80, v equal to u plus 80. In the place of v, we are keeping v striking. In the place of u, we are keeping u. In the place of a, minus z. In the place of small t, we are keeping capital T, which means time of flight. So v striking, u as it is, z as it is. In the place of time of flight, we can substitute formula 2u by z. We can substitute. Z gets cancelled. U minus 2u. U minus 2u means minus u. So v striking is equal to minus u. Means with what velocity? Suppose if we projected the body with 40 meter per second upwards, it will reach the body with same velocity, but downwards. Beginning velocity direction is upwards, which is taken as positive. Final velocity, coming down velocity or hitting velocity is downwards. So that's why we will take it as negative. Its value is minus 40 meter per second. So it means that with what velocity we project the body, with same velocity it will hit the ground, but in opposite direction. But in opposite direction. Okay, children? So next. So here, so at any point, at this point, while going up, at this point, this point, this point, or this point, at any point, if you compare, here the velocity is 9.8 meter per second while going up, while coming down, minus 9.8. Means at the same point, they will be having same velocities, but in opposite direction. So here 19.6, here minus 19.6. Here 29.4. If it comes here, it will become minus 29.4. So here final 0. But because for 0 there will be no plus or minus. So that's why here also 0. Next step. So velocity at a given height means we have projected the body. It is going to somewhere. Maximum height we know, h max. H max equal to u square by 2z. U square by 2z. But we want to find height at certain point. At this point, how much? R. At this point, how much? If we have to find the time at a certain height, at a certain point, then what is the procedure? Okay, let a body be projected vertically upwards with an initial velocity u. The body reaches height, suppose height h, after certain time t. Means we have to assume it reaches certain height h after certain time t. We know one formula, v square plus u square equal to 2as. Here v, final velocity capital V, u, initial velocity small u. Because the body is going up, that's why acceleration is minus z. Displacement, let it be certain height h. So in the place of v, we will keep v, u, we will keep a, u. In the place of a, we will keep minus z. Yes, we will keep h. It will become v square plus v square equal to u square minus 2gh. This square will come this side. Root of u square minus 2gh. Root of u square minus 2gh. So this is the formula for certain height. Means if we want to find velocity at certain height, we want to know that height. We want to know the height. At what height we need velocity, that height we need. Along with that, with what velocity we are throwing it up, that we need. G value constant. G value 9.8 or 10. It's constant, that value. If you know the three values, we can find velocity at certain height. Next one. So here we have to note some point here. So a body can have zero velocity and non-zero acceleration. Means velocity equals to 0, but at the same point acceleration is not equal to 0 at an instant. Means at the same time. So for example, at the highest point in the vertically projected body, at the highest point velocity is 0. Velocity vector is 0. But acceleration, because at highest point, instead of going up, it is changing its direction towards downside. At highest point, velocity is becoming 0. So that's why instead of going up, it is turning downside. Means we can observe change in the direction of velocity, which is called acceleration. So velocity is 0, but still acceleration value is there. That happens at one instant. Next. So distance covered by the body projected vertically up in the first second of its upward journey is equal to the distance covered by it in the last second in the downward journey. So here, suppose this vertically projected body from 0 to 1 second. So the distance traveled by the body in the first second, 2 seconds, 3 seconds, 2 seconds, 3 seconds, coming down, 4 seconds, 5 seconds, 6 seconds. 0 to 1 second is the first second, 5 to 6 seconds gap is the last second. The distance traveled by both the time gaps is equal. Both the time gaps is equal. Okay. And same way, 1 to 2, what distance traveled in between 1 to 2 seconds, between 4 to 5 seconds will be the same. And the formula for this is S equal to U minus G by 2. This is the distance formula. This 1 second, last second distance formula, S equal to U minus Z by 2. S equal to U minus Z by 2. Next one. But here what? First second upward journey, last second downward journey. That curve, that point we have to keep in mind. Suppose if you take like last second in upward journey, first second in downward journey, they are also equal. Means here 0, 1, 2, 3, 4. This 3 to 4 second is the last second in upward journey. This 4 to 5 seconds, first one, 4 to 5 second it is the first second in downward journey. This last second, this first second, they are also equal. They are also equal, but here the distance will be calculated by S equal to Z by 2. By the formula S equal to Z by 2. So if you remember these shortcuts, you can solve the problems easily, children. So you have to keep all these points in note. Now, so motion of a body thrown vertically up from top of a tower. From the top of a tower. So until now, we are throwing it from the ground. But now, if you throw it from the top of a tower, so AB is the tower height here, which is equal to small h. From there, we have thrown it up. It went up to C. This B to C height is capital H. From C, it is falling downwards up to D. Means this C to D is this capital H plus small h, H plus H. Actually, this is a straight line, children. B to C. This is B actually. This is A to B, B to C, same path, C to D. It's the same straight line, children. It's the same straight line going up, coming back. But for showing the values, we have drawn like a curve, but it is not a curve. It's a straight line path. You have to assume it as a straight line path. tower height will be small h, body height above the tower will be capital H. During downward journey, total distance covered will be capital H small plus small h. Next one. AB is the tower height. A body is projected upwards with the initial velocity u from top B of the tower. Body travel upwards, reaches point C, starts falling down from there. Why it is falling down from C? Because the velocity is becoming 0. While throwing from B, we have velocity u, but at C, velocity is becoming 0. Finally, the body reaches point D in the horizontal plane, which is the foot of the tower. Here A is nothing but, D is nothing but foot of the tower, reaching D. So direction of projection is upwards, is positive. Opposite direction is taken negative. Upward values are taken positive. Downward values are taken negative. So upward displacement of the body, capital H, because from here it went to C, it's only capital H. Downward displacement of the body, downward displacement total, H plus H. But upward, positive, plus H. Downward, negative, minus of H plus H. Minus of H plus H. Net displacement. Net displacement means both we have to add. As they are vectors, along with the sign we have to add. Plus H, minus of H plus H. Both we have to add. Plus H, minus H cancel, minus H will come. Means net displacement means this part positive, this part negative, this part cancel, only this part will remain. But in downward direction, minus H. So if we add plus H minus H cancel, only small minus H will remain. Total time means from B to D. B to D, let it be small t. Let it be small t. So displacement minus H, acceleration. Finally, it is falling downwards. Starting is upwards, but finally falling downwards. So minus z. Time of travel small t. Initial velocity u. So we have the equation s equal to ut plus half at square. From this equation, ut half at square means in the place of a we will keep z. In the place of t we will keep t. In the place of h we will keep minus h. Or minus will come this side. Or if we multiply on both sides with minus h will become plus h. Ut will become minus ut. Minus half gt square will become plus half gt square. Or ut we will write here, you can write here, h equal to half gt square minus ut. So this is the value of h, small h. What is h here, children? H is nothing but height of the tower. So if you are throwing from a tower, so then what is the height of tower? Based on this motion of the body, you can identify the height of tower. So height of tower. Height of tower we can calculate, children. So h equal to half gt square minus ut. So means it is x square x. Means it is a quadratic equation where in the place of x we are having t. It's a quadratic equation in time, children. It's a quadratic equation in time. Or we can write it as half gt square minus ut. This h will come this side. Minus h equal to 0. Or half gt square plus of minus ut plus of minus h equal to 0, where it is in the form of ax square plus bx plus c equals to 0. Whose roots are, whose x value is, here x means t, x value is b square, minus b plus or minus root of b square minus 4ac by 2a. Quadratic equation formula. According to that, minus b means minus of minus u plus u plus or minus b square u square plus 2ac b square minus 2ac. Children, b square minus 4ac minus into 1 minute, children. Formula minus b plus or minus root of b square minus 4ac by 2a. This is the formula for roots. Minus 4ac minus 4 into a how much, half z, into c how much, minus h. If you multiply, 2gh will come by small g. Okay, like this we can find the time. So because here we are having plus or minus, so if you keep plus, one value will come. If you keep minus, one value will come. One value will be positive, one value will be negative. So negative time will never be negative. So positive value will be our answer. While solving problems, we can use this equation, and there you will get the clarity, children. Okay, children, this is for time. This is for time. Okay, children, that's all for today. Thank you for watching our video. Please subscribe our channel and press the bell icon for receiving latest updates. Thank you, children. Have a good day.